Indians all over the world are crazy about cricket. Now imagine, it's the final match. India versus England and millions of people are watching. People are watching match from their homes, offices, on their laptops, television, tablets, all at the same time watching the same content. Where? Online. And all this is happening on the streaming platform like Hotstar. So Hotstar is the solution for everyone. Now, what is Hotstar? A platform where millions stream movies, shows and live sports. Why everyone uses Hotstar? Because it delivers live content to millions of users instantly. Now, the match begins and crores of users are already watching the match online. And there's a massive spike. So Rohit and Kohli starts batting and the users jump rapidly from 5 crores to 12 crores within few seconds. That's the hype, that's the spike. Now there's a peak hype moment, a 6 is hit and even more users join instantly. The Hotstar servers are handling increasing traffic every second, overloaded with the requests. There's a sudden drop, silence everywhere. India loses a wicket. Virat Kohli is out. Users getting disappointed, starts leaving the platform. Before 12 crore and now 7 crore people are watching online. The match comes to an end and India lifts the trophy once again. And the users start leaving the application and the platform now. Now think, how does the system handle such massive changes instantly? Crazy, right? So, we have to find out. So let us understand this with a simple analogy. Imagine you are building an application and you decide to build a simple app to stream content to the users. So what do we build? A backend server to handle user requests, a basic application deployed on the server which is designed to support limited number of users. So the application is developed and deployed on the server and the users will be accessing it. So everything is working fine initially. And your application works perfect when only few users are connected. So 100 users capacity is the capacity of the server. A single server is handling all the users smoothly at first. Now there is a traffic spike. Suddenly users start increasing rapidly beyond the server capacity. The app is getting viral. So what happens? The server gets overloaded and crashes due to the excessive traffic. That's the problem. So what's the immediate solution to this problem? Let's add more servers and let's see if this could be fixed. So developers start adding more servers manually to handle the growing traffic. But wait, what if the traffic drops? Do we still need more servers? No, right? We need to delete them to save costs. So less user and more server is equals to bleeding money. After traffic drops, extra servers still running cause unnecessary cost to us. So what did we just see? Single server cannot handle sudden traffic spikes, manual scaling is slow and error prone, server crash under heavy load, extra servers keep running after traffic drops, and this leads to high infrastructure cost. That's the problem. So we need a system that automatically scales up when traffic increases, automatic scale down when traffic drops, handles failure without downtime, reduce manual effort and optimize infrastructure cost. So this is where Kubernetes comes into play. So still confused? Let's understand how Kubernetes comes into play. So there is a critical question that first we developed the application and we deployed it on the server. That's how people will connect to that application. So application is equals to the source code plus the dependencies. So the dependencies are the programming runtime, maybe Python, Node, libraries and packages like Fast API, React, operating system, system dependencies, all these are packaged and then it gets deployed on the server. But the traffic spikes. And how do I install the application along with its dependencies on the server? That's tough and full of errors, right? I need a solution where all the servers can be provisioned exactly the same in the real time without errors. So the solution is Docker. So what is Docker? So Docker allows us to package our application into something called as container. And what is a container? Think it of just like a box. Inside this box, we put everything that application needs, the codes, the libraries, dependencies, configurations, wrapping them in a single container. Why this container matters? Now, no matter where we run this container on any server, it behaves exactly the same. So the problem that Docker solves is like every server had different configurations earlier, which caused failure. But with Docker, everything is packaged together. So the environment becomes consistent. Now, before Docker, app breaks and why there was a dependency mismatch. Now, same container everywhere and stable behavior. So how Docker helps in scaling? Now the scaling is easier. Instead of setting up new servers manually, we just run more containers. We don't scale servers anymore. We scale containers. But there's still a problem. So now we have hundreds of containers running across multiple servers. How to manage them? Now the challenge is like who will manage them, who will scale them, who will handle their failures. So this is where Kubernetes comes into play. So Kubernetes is extremely powerful. And at the same time, Kubernetes can manage everything automatically. So Docker solves the consistency problem, but it creates a management problem, which leads to Kubernetes. So Kubernetes manages all the containers. So Kubernetes was all I needed. So Kubernetes does load balancing, Kubernetes does healing, scaling, deployment, reliability, everything. So this was what I needed. So that's all about a quick introduction upon Kubernetes. So that's why we needed Kubernetes. Thank you so much for watching. Stay tuned for more videos.